Let's take a look at this problem that was on your test last week. A builder needs to make a box with a square bottom and rectangular sides. The box has no top. The material for the sides will cost $2 per square foot. That's important, so I'll underline that. And that's for the sides. The material for the bottom costs $4 per square foot. That's important as well, so I'll underline that. What is the largest volume box? So we're going to maximize the volume that the builder can make with $20. So this is our fixed cost of $20. So first of all, let's recall that volume is equal to length times width times height. And this is a square bottom box, so I'm going to call these sides X and X, and we'll call the height H. So our volume is actually going to be, in this case, X squared times H. And we're going to be trying to maximize the volume for this particular fixed cost. Now notice that the box has no top, so I don't have to worry about the area of the top. But the area of the bottom is X squared. Let's come up with a surface area formula here. So the area of the box is the area of the bottom, and the area of the bottom here is X squared. Plus, we need to add on the area of the lateral faces. And so that would be the area of one of these faces. And there's 4 congruent rectangular faces like this. And the area of this face would be X by H. And there's 4 of them. So our lateral area is 4X times H. And we know that the surface area, or the cost, is based on the surface area. So let me come up with a cost function. The cost is $4 per square foot for the bottom, so I have to take the area of the bottom times 4, plus $2 per square foot for the sides, and this is the area of the sides, so I need 2 times the 4x times h. And I know my cost is fixed at $20. So I have 20 equals 4x squared plus 8xh. Now our goal here is to find the largest volume box. So we have a fixed cost that we're working with, which means a fixed surface area. But we want to find the largest volume that is met by this function, or this constraining function here of 20 equals 4x squared plus 8xh. So what we need to do is solve this equation, first of all, for either x or h to substitute into our volume equation. Let's solve this for h. So to solve this for h, I would subtract 4x squared from both sides, and then I would divide by 8x. And so this right here is going to get substituted into h, into our volume equation. So let's rewrite our volume equation. So we'd have v equals x squared times our height. And I'm going to, well, let's just write it this way. We'll distribute the x squared in a minute. Let's distribute that x squared. So we're going to have 20x squared minus 4x to the 4th all over 8x. Now we need to take the derivative to get the maximum volume. However, we might want to simplify this first, because otherwise we'll have to use the quotient rule. So let's simplify this first. I can divide x out of each term, and I can also divide 4 out of each term. So let me do that. I would have 5x minus x to the 3rd over 2. That looks much simpler. I could even split this up into 2 separate terms of 5 halves x minus x to the 3rd over 2. And so now we're ready to take the derivative. So we'd have v prime equals 5 halves minus 3x squared over 2. And then to figure out where we have a maximum, that's where the slope of the tangent line is equal to 0. So we set our derivative equal to 0 and solve for x. clear the fractions to begin with, multiplying everything by 2. And then I'm going to have 5 equal 3x squared. Dividing by 3, I have 5/3 is equal to x squared. So that means that x is equal to either plus the square root of 5/3 or negative square root of 5/3. Now I know I can't have a negative length, so even though negative the square root of 5/3 is a solution to this equation, it's not a solution to this problem. So I'm going to find a decimal approximation for the x value that we have, and that decimal approximation would be about 1.29 if you substitute this into your calculator. Now let's see if we've answered the question. The question is, what's the largest volume box? So actually I need to figure out the volume and calculate x squared times h. So let's do that. I need to actually get the volume by calculating x squared times h. So remember x was the square root of 5/3. You just square that, which will be pretty easy, but then I have to multiply it by h. And remember we had an expression for h way back up here of 20 minus 4x squared over 8x. Although we did simplify that to 5/2 x minus x cubed over 2. So let's do that. 5/2 x minus x cubed over 2. And remember x was the square root of 5/3. So 5/2 x minus x cubed over 2. That's the calculation we would need to do to get the volume. It does end up being a little messy, but when everything is said and done, you should get a volume of 2.16 cubic feet. And I know the units are cubic feet because we're talking about the price per square foot here. So our final answer to the question is our maximum volume based on this constraint of $20 for the cost of the material. Our maximum volume is 2.16 cubic feet. We'll be having a quiz on a problem similar to this on Thursday, and that'll give you an opportunity to show me that you understand how to do these types of problems.